Ladies and gentlemen, welcome to our continuing exploration of circles in our video lesson 10-4, basically on inscribed angles. Here we go, here we go. First of all, there's 4 theorems we're going to learn here, and I'm going to go through them quickly, okay? The first one says an inscribed angle is always half of its intercepted arc. Let's talk about what an inscribed angle is. An inscribed angle is an angle where, let me make this bigger here so you can see it. An inscribed angle is an angle whose vertex is on the edge of the circle. Okay? So in an inscribed angle, the angle x is always going to be half of its intercepted arc. So the measure of the set of the inscribed angle is half of the arc that it intersects. And please know that all of these theorems go both ways. Okay? All these theorems in this lesson are what we call biconditional. They go both ways. So if the angle is x, then the arc is 2x, or if the arc is x, we can go backwards. The angle would be half of that. Okay? Let's go on to the next theorem. Theorem 2 says if 2 angles, inscribed angles, both cut off the same arc, then those angles are congruent. So if this angle, the red angle, is an inscribed angle, notice its vertex on the edge of the circle, it cuts off this arc here in green. The blue inscribed angle also cuts off the same arc in green. Therefore, the blue angle is congruent to the red angle. They both cut off the same arc. The third theorem says if an inscribed angle is a right angle, so here's my inscribed angle. It is a right angle. It then cuts off an arc that is a circle. And of course, that makes perfect sense because an inscribed angle that's a right angle has a measure of 90, and its arc is a semicircle because it has a measure of 180 or double 90. And again, this theorem goes the other way. If I have a semicircle with a measure of 180, therefore now the inscribed angle that cuts that off is going to be a right angle because its measure is half of 180, which is 90. Okay? And our fourth theorem says in a circle, if I have an inscribed quadrilateral, then any 2 opposite angles in the quadrilateral are going to be supplementary. What that is saying is that these 2 angles, angles A and C, are sup. They add up to 180. Remember from before, supplementary means adds up to 180. And angles B and D, they are opposite each other, so they are also sup. They add up to 180, and this theorem makes perfect sense. If you look at the picture, let me just get rid of this real quick. If you look at the picture, we can see that angle D cuts off this green arc, and angle B is going to cut off this blue arc. Well, the green plus the blue add up to 360, which means the angles which are half of that are going to add up to half of that, which is 180. Okay, let's try some problems real quick. Let's find the measure of angle B. The measure of angle B is right here. It is an inscribed angle, therefore it is going to be exactly half the measure of its intercepted arc. That intercepted arc has a measure of 60, so 1/2 of 60 is equal to 30. So that's the measure of angle B. If we look at this one, we are looking for the measure of arc, RT. There's my arc, RT. It is opposite an inscribed angle of 63, so I know the measure of the arc is 2 times the inscribed angle, which is now 126 degrees. Why don't you guys try these 2, and I'll come back in just a momentito to see how you did. Alrighty, guys. Okay, let's go over these answers real quick. The answer to number 5, measure of angle H is 54. And number 6, the measure of angle B is going to be 36. Why don't we do some algebra and figure out how we got those answers? Here we go. Measure of angle H. Let's see. Let's take a little look-see here. Notice that measure of angle H is an inscribed angle that cuts off this red arc JK. G is also an inscribed angle that cuts off the same arc. Okay. Therefore, those two angles must be equal. So I know that x is equal to 2x minus 54. Doing a quick little bit of algebra, I'm gonna minus x on both sides and add 54 on both sides. So it looks like I get 54 is equal to x, and that was my answer. Measure of angle H is x, 54. Down here, once again, I see that angle B cuts off this arc AD right here. I also see now that angle C cuts off the same arc, AD. Therefore, angle A is congruent to angle C. So x plus 24 is equal to 3x. Let's subtract x from both sides. I'm going to get 24 is equal to 2x divided by 2. Both sides, x is 12. Well, that's not my answer, so I'm looking for the measure of angle B, which is x plus 24. 12 plus 24 is 36. Okay, looking at this problem right here real quick. This is a little bit interesting. First of all, I see a trapezoid, possibly, but certainly a quadrilateral inscribed inside of a circle. I don't know if it's a trapezoid, but it may or may not be, and it's not necessary for the information. More importantly, what I do see is I see 3 chords, or is that shorts? 3 chords are all congruent. If you remember from section 10-1 and 10-2, congruent chords mean I'm going to have congruent arcs. So this blue arc is congruent to this blue arc, is congruent to this blue arc. And I can now figure out I have the 3 blue arcs plus the 120 down here in, let's color that one, I'm not going to do it green. Okay, so this green arc, which is 120, plus the 3 blue arcs, add up to 360, right? So I know that each of those missing pieces must be, see, 120 plus 3 of the blue arcs, let's call that x, is equal to 360. So therefore, I now know that 3x is equal to 240, and each of those little arcs is equal to 80. So I'm going to write those in right now. 80, 80, and let me get rid of this stuff right here, and 80. From here on in, I'm going to let you finish this problem yourself. To figure out what each of these angles are, you can use a number of things. If you notice, and I'll do this in bright yellow so that you can see it, angle A, for example, is an inscribed angle that cuts off this yellow arc. So that's going to help you. Also, you can use the fact that angle A and angle C are going to be supplementary. So that's going to help you. Same thing with B and D. And you can use the fact that all these angles, sure enough, are inscribed angles. Okay, so our answers are 80, 100, 180. I'm hoping you got those. And let's do one more problem before we wrap this section up. Find the area of the shaded region of the circle. The inscribed rectangle, and it does tell us that it's a rectangle. That's important. So that means that these are all right angles, okay? It is 30 by 16, and they gave us that. Here's the key, using the stuff we learned from this chapter. If I have a right angle right here, I know the inscribed angle that's a right angle is going to cut off a semicircle. So this blue arc right here is half of the circle, which means it's a semicircle, which means now that the diameter of the diagonal of my rectangle is indeed a diameter of the circle. which means now ding, 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 ding. If you look right here, we have a right triangle. This is 16, this is 18. This must be 34 because it's 8, 15, 17 times 2, which is 16, 30, and 34. Now I know my diameter is 34, which means my radius is 17. Let's do a little bit of work right now. I need to find the area of the circle minus the area of the rectangle. Well, the area of the circle is going to be pi times the radius squared. The radius was 17. 17 squared is 289. Minus the length and the width of the rectangle is 16 times 30. 289 pi minus 480. If you care, we can write that as a decimal, which is going to be 427. Oh, I can't write and talk at the same time. 427.9. There we go.